So vector is a quantity that has both magnitude and direction. And you can represent it by an arrow array. Magnitude is a length of the vector, and direction is where it's heading, where it's pointing. And we're going to use the angle. We don't really use radians for directions. Okay? So first, vector in plane. Two-dimensional vector V is basically an arrow on the coordinate plane. And you will have 2 points, right? Where you start, which we call an initial point. This is an initial point. And where you end will be called terminal point. So if you have 2 points where you start and where you end, you can write a component form of a vector and find the magnitude and direction. We also call this what? Head. And we call this tail. Okay. So what do we do to find the component form? We can use 2 points to draw the vector, but now we're going to write it in a component form. So component form, now we change the bracket to carets, triangular brackets, not parentheses. And what it means is it starts from always the origin to point A, comma B. That's a component form of A, comma B. Again, it always goes from 0, 0 to these 2 points. So how can we find the component form? We can use the head minus tail method. What you do is, this is head and this is tail. Then you will subtract tail from the head. So for example here, head is 5, 6. Tail is 1, 2. Then now you can find the component form of a vector. 5 minus 1, which is 4. 6 minus 2 is 4. So now 4, 4 is a component form of a vector. So what this means is, again, by the definition of component form, it is a vector that's always start from what? The origin, 0, 0. And it goes to 4, 4. Here's 4, 4. So now we call it 4, 4 vector. And as you can see, these 2 vectors are the same. So we are just moving one vector, so it will have its tail to 0, 0. Tail at 0, 0. That's what component form is. So if you had something over here, the x was 4, increased by 4, going up by 4. This will have a same component form, which will be 4, 4. Because if you move this arrow to 0, 0, it will end at 4, 4. That's a component form of a vector. Okay. So here, now they're giving you these 3 points, and they want you to determine the component form of vector PQ. So what would you do? Head minus tail. So you just got to know which one is your head and which one is your tail. Which one is the head? Q is your head. So you will do Q minus tail, which is P, to get the component form. So what's Q? Negative 3, 1 minus P, 2, 6. So now it changes to a component form. So x component of this vector will be what? Negative 3 minus 2, which will be negative 5. 1 minus 6, which will be negative 5. That's a component form of vector PQ. So how would this vector look like? It will be from 0, 0, negative 5, negative 5. So here's your vector PQ. Probably they started at P, which is 2, 6, 2, 6. And you still have a same direction and magnitude, so it will go somewhere like this. You see how they are same vectors? PQ. But component form is what? Just move your vector to 0, 0. Why? Because it gives you an easier form to find the magnitude and direction later. So number 2, determine the component form of vector QR. What's the head of vector QR? Whatever is under the arrow is the head. So it's R minus Q. So R is -4, comma -5 minus Q, which is -3, comma 1. So now the component form, make sure you change it to caret. -4 minus -3 is +3. So we get -1, comma. -5 minus 1 will be -6. That's a component form of a vector QR. Okay, just remember head minus tail. And we will have our first exit card on Tuesday on these magnitude and component form and addition and subtraction. So now we're going to find the magnitude. Again, what is the magnitude of vector? It's the length. So here you can use, as you can see, you can use a Pythagorean theorem or distance formula to find the magnitude, as you can see. But first of all, you need to know the notation of a magnitude. This, you see the bars around the vector? Absolute value, but it's not an absolute value. It means the magnitude of vector V. And there's two ways to denote the vector. You can either write vector, arrow sign with V, or whenever you see a bolded letter, V, that's also a vector. They both represent vectors. Okay? What is the magnitude of vector? Whenever you see these square, or we can think of it as what? Absolute value means the magnitude. So on the test, they're not going to say find the magnitude or length of the vector. They can just say evaluate this, meaning you have to find the magnitude. Okay? So this is a distance formula, right? So what you can do is you can use a distance formula from these 2 points or find a component vector which already gives you a distance from 0 to 0, 0 to the head. So first find the component form and just do the Pythagorean theorem. Remember this vector we got, oh, this is a different vector. First find the component form and then just do this rather than finding the difference. So what is the component form of vector Q and vector QP? You do head minus tail, which is now component of 4, 4. Oh yeah, it was actually 4, 4, not 5, 5. Then how do you find the magnitude of this? Just do square root of 4 squared plus 4 squared, which is a squared plus b squared equals to c squared. Then you do square root it. So then you get square root of 16 plus 16, which is 32. So you get what? Think of any perfect square goes into 32. Yeah, if it was non-calculator, you should know how to simplify a radical. So what perfect square goes into 32? 16 times square root of 2, isn't it? Square root of 32 is square root of 16 times square root of 2. So what is square root of 16? 4, and you get root 2. Okay? So now, find the magnitude of vector PQ. Yes. So here, you can either do the distance formula or, again, it's easier to find the component form first. So what do? It's Q minus P. So 4, -6 minus Q, no, P minus P, 3, 7 So you get component form of 4 minus 3 is 1. Negative 6 minus 7 is negative 13. Are we done? No. You're looking for the magnitude. So now what would you do? So magnitude of vector PQ is now square root of always these two, square and edit, right? 1 square plus. And if I were you, instead of writing negative 13 squared or with parentheses, just write 13 squared. Negative 13 squared must be same as 13 squared. Okay? Unless you put parentheses around negative 13, just put positive 13. So then what do you get? Square root of? This is 169 plus 1, 170. So does any perfect square go into 170? So think of 25, right? 25 is a perfect square, but would it go into 120? I mean, 170? No. And all the other numbers will not give you exactly 0, so no. Then, let's say this was on the calculator section. Give me the rounded answer with 3 decimal places. Square root of 170, plug into the calculator. What do you get? 3.8. Yeah, that will be your magnitude of this vector. Yeah. So here's another term. Whenever we say the vectors are equivalent, the same, when the vectors have a same magnitude and direction. So it basically means if they have a same component form, then they are equivalent. Okay? So prove that vector PQ and RS are equivalent by showing that they represent the same vector. So again, if they have a same magnitude and direction, meaning same component form, they're equivalent. So what is vector PQ? It's Q minus P. Q is 7, 1 minus P, 4, 6. So you get component 3, negative 5 for vector PQ. And now you're doing vector RS, which is S minus R. So S is 1, negative 2. R is negative 2, 3. So I get 1 minus negative 2 is plus 2. So 3, negative 2 minus 3 is minus 5. So are they equivalent? Yes, when they have same component form, the vectors are equivalent.